Now let's talk about System Explorer. System Explorer is on the left hand side of Zemax, and we always have access. Even when you change the ribbons or tabs, you can always have access to these parameters. And those parameters usually are the parameters that we set them, and we don't change them during the design. And usually we set it before the design started. And then when it gets matured, we are not going to change it. So first we have object stop image. We have nothing. Let's go to analyze. Let's look at the cross section. We have nothing here. Let me put it here. So on the System Explorer, we can actually hide it, unhide it, or we can get access to these windows from here also. The first things that we set is aperture. So for the aperture, we have aperture type, we have entrance pupil diameter, image space f number, object space numerical aperture, float by stop size, paraxial working f number, and cone and object cone angles. Usually, most of the time, we use entrance pupil diameter and float by stop size. So for entrance pupil diameter, we have a beam that comes at the pupil diameter at infinity usually. That, for example, we can set it for 20 millimeter. That we have a beam that comes from infinity with the aperture value of 20 millimeter. Or the other option is to float by stop size. So it means that the limitation of on our beam is the clear semi-diameter of the stop of our optical system. So right now I'm gonna select entrance pupil diameter, and let's say we can put 20, 25, any number. So 25 millimeter. Apodization type is the kind of distribution of our rays. So we usually select uniform. Gaussian means the distribution of the beam is going to be Gaussian. Cosine cube is a different distribution. But right now we're going to select uniform. Clear semi-diameter margin millimeters. This is not that important. We put a margin for our mechanical edge. That's not that important for us, from the clear optical clear aperture to mechanical semi-diameter. And clear semi-diameter margin in percentage, we are not going to change it. Global coordinate reference surface is we're going to select 1, which is the stop of our optical system, and the rest we are not going to change it because those are not that important for our simulation. So that was the aperture. Maybe yours is a little bit different than mine, because as I mentioned before, for example, if polarization is important for you, you can drag polarization and put it close to the top. Or so for me it's like this, but you can change the position of the System Explorer items. Now let's select wavelength. Wavelength is the wavelength of the light. The default wavelength is at 550, which is close to green light. We can change the wavelength by clicking on the wavelength. I can, for example, change it to Heine laser 633. Or the other option is that I can double click on select, and I have wavelength data. Let me put it here. So I have all my wavelength data. I can add another wavelength, let's say 532. I mean 532 because the wavelength is micron unit. So we have different wavelengths. We can select the primary. So right now I changed my primary to 532, and the primary is the wavelength that all the optimization is based on that wavelength. But for visual things like camera or eye, we use FDC visible, which you select. You have different options, but right now we're gonna select, as I said, Heine. We have different wavelengths for even SO2 laser. So we're gonna select FDC and select preset. When you click on that, then we have the 3 main wavelengths of the visual: blue, green, and red, which is RGB. Now we have 3 wavelengths, and the primary is for green because our eye is most sensitive to green. Now we're gonna save it. Oh, sorry, we don't need to save the data. Click on close. So right now we have 3 wavelengths listed with the same weight actually. Weight of each of them is 1. So I'm gonna close it. That's the wavelength. For the field, is the points on our CT that we want to have some kind of points that we can see the result of imaging on those points. So for now, I'm gonna select only have, we can click on open field data editor. Now we have only one field on the optical axis because X angle and Y angle is at 0. I can add one more field. Let's insert a field after at 5 degrees. Like for our eye, the phobia is at 5 degrees. So I'm gonna select one field at 5 degrees. Polarization is not that important for us. Environment is related to the temperature. That is not pretty important for us. Advanced, we don't need to touch those parameters. Ray aiming, that's okay, we don't need to change it. The material catalog for eye, we're gonna put the numbers for the refractive index from the resources that we have. But for if you want to use glasses, we can add catalogs here, and then we use those are the listed catalogs that are available. So we are not gonna touch it. Title and note, we can put a title for our file, we can put the author, we can put a note. And files, this is the coatings data that we have gathering. In different system folders, you can have different coatings data and you can reload them. So right now we don't need to do any change because we don't have any coatings data. And the units for the lens unit is based on millimeter. Source unit prefix, we don't need to put anything for that. Source unit is watt, or we can change it to joules or lumens. Right now watt is okay because we're going to work on SI unit. Analysis none, watt per centimeter squared, we don't need to change it. And the rest, cycle per millimeter for MTF, that's okay. And the cost estimator is also another thing that is not that important for us for eye simulation.